GCSE Design Technology Core Area Mechanisms. In this tutorial you will learn different mechanisms, how to calculate mechanical advantage, how to calculate velocity ratio and output speed, cams and motions. You'll also have the opportunity to create revision flashcards. To start with the revision flashcards, you may want to do one on the next category that I'm doing, which is motions, levers. There are 4 types of motion. The first type is a linear motion. This is moving forward in a straight line, like the tortoise on the skateboard. Motion 2 is a reciprocating motion. This is a motion moving up and down, like a weightlifter. The third type of motion is a rotary motion. This is moving in a circle, like a Ferris wheel. The last motion is an oscillating motion. This is moving backwards and forwards, like a swing. There are 4 types of mechanisms. There are levers and linkages, like a seesaw, gears, pulleys, and cams. Going to start with lever. Every lever has a load, effort, and a fulcrum, or a pivot. The load is what you are moving, the effort is the force applied to move the load, and the fulcrum, or the pivot, is the point that it is moved on. There are different class types of levers. A class 1 lever has the load and the effort on the opposite sides of the fulcrum, like a seesaw or the pair of scissors shown. A class 2 lever has the load and the effort on the same side as the fulcrum. An example of a class 2 lever is the wheelbarrow shown. A class 3 lever has the effort and the load are both on the same side as the fulcrum, but the effort is closer to the fulcrum. For example, the tweezers. Mechanical advantage. Levers can be used to increase our strength. With a long lever, a small force can be used to raise a large load. This gives us mechanical advantage. The calculation for mechanical advantage is shown. MA equals load over effort. Here is an example. The load in the wheelbarrow is 50 newtons. The effort applied is 10 newtons. We therefore do 50 divided by 10 equals 5 MA, 5 mechanical advantage. Types of cams. There are different types of cams. Here shows 3. The offset cam. The offset cam is a circle with the drill hole slightly offset to the centre. This means that when it moves, the follower will move around the cam, allowing it to move slowly up and down. Pear-shaped cam. This is slightly pointed at one end, meaning that when the follower moves, it will go higher in one place and lower in another. Finally, the snail cam. The snail cam has a slight section taken out of it, meaning that when the follower goes around, it slightly jumps and drops quickly. We are now moving on to gears and calculations. If you are creating a flashcard, you need to write down the calculation for mechanical advantage as shown. We'll learn the different types of gears and how to calculate velocity ratio and output speed. Different types of gears. First type of gear is a bevel gear. This gear is used to change rotational motion through 90 degrees. This is similar with a worm wheel. A rack and pinion, this uses gears to change rotation to a linear motion. For example, a stair lift. The last type of gear is a bell crank. This changes the direction of the force through 90 degrees. Calculating velocity ratio, or gear ratio. Below shows an example of the drawing of a type of gear. It shows the driver gear of 60 and the driven gear of 15. This is how to calculate the velocity ratio. You divide the driver gear by the driven gear. So in this example, it would be the driver gear of 60 divided by the driven gear of 15, which would equal a velocity ratio of 4. That means that the smaller one will turn 4 times for every time the big one turns once. This is a 1:4 ratio. If you would like to have a go of more of these, I have put some examples shown. Pause now so that you can have a go. If not, I will go through the answers. The first one, 80 divided by 12, 6.6. Number 2, 20 divided by 8, 2.5. Number 3, 90 divided by 6, 15. Number 4, 75 divided by 20, 3.7. Number 5, 85 divided by 7, 12.1. Number 6, 98 divided by 4, 24.5. We are now going to look at how to calculate output speed once we have the velocity ratio calculation. Looking at the diagram again, it's the same diagram with the driver gear at 60 and the driver gear at 15. However, in the top corner, it's moving at a rate of 200 RPM. We have to calculate what the output speed would be. The calculation for this is output speed equals input speed divided by velocity ratio. We need to calculate the velocity ratio first. The velocity ratio is 60 divided by 15, meaning that it moves at a rate of 1:4. So 4 is our velocity ratio. Our input speed is 200. So we do 200 divided by 4. This would give us an equals of 50 RPM. That would be our output speed. If you wish to use this for revision in the future, I advise you to do a flashcard on mechanisms questions. Here are some to get you started. You can then review your learning later. Thank you for listening.